In this video we are going to take a look on how to use shaders with cocos2d Python, and of course what are shaders. So shaders are programs which runs on your GPU, so the graphical processing unit, and we can use multiple shaders. So we can have a Vertex shader, Fragment Shader, Tessellation shader, or I don't know, Geometry shader. But in this video we are just going to create two shaders, the Vertex and the Fragment shader. And okay, so the first thing, I'm going to import from cocos2d shader, import the shader program, the Vertex shader, and the Fragment shader. So you can go to the python.cocos2d.org and go to the docs and tutorials, and here in the API reference, if you scroll down in the submodules, you will find the cocos.shader module. And we are going to use this Vertex shader, this Fragment shader object or class, and this shader program class. And this shader program class has all sorts of methods, so destroy, install, link, prog, set shader, and all these uniform locations, uninstall, use one f, one float, use one I for one integer, use 2f for two floats, use 2i for two integers, use 3f, 3i, so 3 floats, 3 integers, or use t for f, and this is for 4 floats, and of course use tm for f, which is a matrix. And for the matrix stuff, I'm going to use the Python peer module. So just type in Python peer, and here you will find the GitHub repository for the peer. And the peer is mathematical. It provides 3D mathematical functions using the power of NumPy. So it can create matrices, 3x3, 4x4, quaternions, vectors, 3D vectors and 4D vectors, and it has all sorts of other useful functionalities. And you can find documentation here, so peer.readthedocs.io. Just go here, and if you want to know more about peer, just read this documentation. So for that I'm going also import from peer, import the matrix 44 and the vector 3, and you can install peer in your terminal or PowerShell or command prompt with the command pip install peer. So I already installed it, so it says that requirements already satisfied. Okay, now I'm just going to create a separate class for my shader stuff, and I'm going to name it just Init Shader for initialize shader. You don't need to create a class for this, but this is the way I like to do things. So I'm going to create just a static variable here called shader, and it will start as none. And the first thing I'm going to or rather the second thing I'm going to create in this class is the Vertex shader source. So vert_src, and it will be equal to a string. So the first thing, I'm going to define which version, which GLSL version I want to use, and of course cocos2d is built on Pyglet, which is built on OpenGL. So, and OpenGL's shader programming language is called the GLSL. So now we are writing the GLSL code, and I'm specifying that I want to use GLSL version 1.3, which corresponds to OpenGL version 3.0. Okay, so hashtag version 130, which is 1.3, and I'm also going to create a new uniform matrix 4 type, and I'm going to call it VP for the view projection. And the uniforms are those types which can be, I mean, from your application you can send data through uniforms to your Vertex shader or to your Fragment shaders. And this is the type of the data this Vertex shader will get from this uniform, which is a matrix 4 type. So then I'm going to create the main function. So every shader has its main function. So if you are familiar with C or C++ or even Java, uses main. This is so-called main entry point. So, and in this main function, I'm going to set the GL position, which is a built-in variable, and it is, I think, yes, it is a vector 4 type. So GL position to the view projection times the also built-in variable into GLSL version 1.3 called GL Vertex. If you are using more recent version of GLSL, so you can use also 3.3. This GL Vertex is deprecated, so it won't work. So that's why, because I want to use this GL_Vertex, that's why I decided to use the GLSL version 1.3. So, and now let's set also another built-in variable, which is the GL text chord. So GL text chord, and GL text chord sub 0 index 0, and set it to GL multi-text chord 0. Okay, so now let's take a quick look what this GL text chord and this GL multi-text chord 0 means. So I just typed here in Google GL multi-text chord, and I'm going to open the first. So GL multi-text chord sets the current texture coordinates. Here are also all sorts of multi-text chords. And let me see. Okay. Yes, here is GL multi-text chord is only supported if the GL version is 1.3 or greater. Blah 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 blah. So go to the GL multi-text chord 0. it says GL multitext code 0, texture coordinate of the texture unit 0, which is a vector 4. So okay, I don't wanna go too deep into these things because programming in GLSL is another programming language, it's not Python. So I'm just going to write just these very simple GLSL codes. And now I'm going to define the fragment shader, so frag_src and is equal to a string, not farg, but frag, okay. And in the fragment shader, I'm also going to specify the version, so GLSL version 1.3, and I'm going to create here an output, or do I need an output color? No, I don't need. I'm just going to create here another uniform, and it will be a type sampler2d, uniform sampler2d, and I'm going to name it samp texture for sampler texture. And I'm also going to create here the main function, so void main, and in the main I'm going to add the built-in GL frag, I think it's called frag color, with capital F, GL flag. I need to double check it, so GL, the book of shaders, okay, yes, GL frag color, capital F, capital C, capital F, capital C. So I'm going to set the GL frag color to the function texture 2d, which is also a built-in function in GLSL. So texture 2d, and give it the samp texture as a first argument, and the second argument is the GL underscore text chord 0, so which is the same as this one, so GL text chord and at index 0. And also don't forget the semicolons. And I think that's all I wanted to add to the fragment shader. So now I'm going to just create in this class two static methods. The first will be the def init. We don't need self. And I'm also going to decorate it with the static method. So def init, and for now just pass, and also another static method, and it will be the def setup the view projection, and just pass for now. So first I'm going to define this function, which sets up a view projection matrix, and of course that's why we need the peer model. So the first thing, I'm going to create a view matrix. So view equals to matrix 44 that create from translation, create from translation, and these as an input needs a vector 3, so vector 3, and in the vector 3 you need to pass a list, so 0 0 0 0 and -1.0. So it will create a view matrix, and this view matrix or translation matrix, and it will translate on x0, y0, and on the z-axis -1. So now let's create an orthogonal projection matrix, or an orthographic projection matrix. So I'm going to call it ortho for orthogonal or orthographic, and from the matrix 44 that create underscore orthogonal projection matrix. So matrix 44 dot create orthogonal projection matrix. Okay, and now it needs left bottom, then the right side, so our screen or window is 1280, and also on the these two values are let me see if I can open this out, go to declaration, so left, right, the bottom and the top, then the near clipping and the far clipping plane. So okay, so this is the left of our window, the right. Now define the bottom, which goes from 0 0 to 720, or which is our this is a screen width and this is a screen height, or the Windows width and the Windows height. So left, right, bottom and top. And for the near clipping plane I'm just going to give it 0.1, and for the far clipping plane I'm going to give it 100 for now. So these are these two values, near and far. Okay, let me take a look. Yes, we now need a view projection, which will be a multiplication of these two matrices. So I'm going to multiply the view with the orthographic projection matrix. So that's why I'm going to name it VP for view projection. And with using matrix 44 that multiply and give it the view and the ortho. The order of the multiplication is important, so just if you don't want strange results, that's multiply it in this order, so view with the ortho, not the ortho with the view. I mean first the view and then give it the ortho in this multiply. And of course we need to flatten this out, this matrix, so we can call the dot flatten, because by default peer uses numpy, and the returned matrix will be I mean a multi-dimensional array. So and we need to flatten this out only to one-dimensional array of numbers. So I think the next thing I'm just going to set is calling the Init Shader, which is this class. I'm going to use the shader, which is for now just none, and shader.use tm4f, which is if you go to back to the cocos shader module, is this last function. So use tm4f, so matrix for floats, and it needs the uniform and the matrix. And for the uniform, I'm going to send these matrix into this uniform matrix for VP, so the view projection. So just give it inside quotes the VP, so it needs to have the same name as it is in the Vertex shader, so VP and VP. And the second argument is the matrix itself, which we just created here, view projection matrix. So, okay, this video will be long, so just stick with me. We are going to define one more, one more function or method, which is this init, which is also a static method. So, okay, so in this init method, I'm going to give the init shader. I'm going to make it a shader program object. So this init shader is this shader. So now this is no more none, it become a shader program object. And I'm also going to call the init shader and set shader, and give it the vertex shader. Vertex shader we imported here. Vertex shader. So vertex shader, and I'm going to name it just vert and give it the vertex shader source. So init shader dot vertex source, which is this one. So init shader dot vertex source. Now let's create the fragment shader. So shader dot set shader and fragment shader, and the fragment shader we imported here from the cocos2d module. And I'm going to name it just frag, and also init shader dot frag source, which is this string here. Okay, I'm just going to this vertex shader class declaration, and okay. Okay, so now this set shader will compile this vertex source and also this fragment source, and it will just compile and send it down to the GPU. So now the GPU can use it, and the last thing with this shader, we need to install it. So init shader.shader and call the install method. And this install in the cocos2d, here in the shader program, here it is installed. And if you go to the shader program object, go to shader program declaration, you can read through this, and here you have the install, and it just calls the GLUse program object. Okay, and the last thing, we are going to call the Init Shader .setup view projection, so this function. So first we creating a shader program, then we are setting the Vertex shader and the Fragment shader to this shader program. We are installing the shader program, which just calls the GLUse program, and when the shader is set up, we are creating a view and an orthogonal projection matrix, and setting this uniform to that view projection matrix. So okay, I think that's all I wanted to do in this shader class. And now, first of all, let's run this program. So we have this UFO sprite sheet animation. We can move it with the keys, or I can move it with the keys. And for now, the shader does nothing. So in order to apply the shader to this scene here, let's say after I created this UFO layer, or after the window that pop handlers, I'm going to call the init shader.init, and the init shader.init will call this static method. And now let's test it if it works or not. Hopefully it will work. So okay, GLX failed to compile. Okay, GL color is deprecated after version 1.2. Yeah, I did not know that. Okay, then we are going to change the GL color. If it's deprecated, it means we cannot use it. So I'm going to create an output type vector4, and just name it out color. So output type vector4 out color, and instead of using the GL color, I'm just going to set to this texture 2D to this out color, and hopefully it will work now. Okay, GL text code is deprecated after version. No, I tested it earlier and it worked. Text code. Oh, let's try to set it to 1.2, GLSL version 1.2, but I'm pretty sure it worked when I tested it before recording. No, I'm set it back to 1.3 because now it says that non-varying out color. So in 1.2 we need to set it instead of out to a varying type or varying type is vector 4, but I'm just going to try this debug off screen, and if I find a solution I come back. Okay, I have a small bug in the Fragment Shader. Just I need to set the GL text chord at index 0.SNT, or you can also use .x and y, but because these are text coordinates, we are just going to use the SNT, which are just in let's say in Blender this is called UV coordinates. So, and now when I run it, it works fine, although now it's just a simple pass-through shader, so it does nothing to the pixels of this UFO. So let's test it, that it works properly just by here in the out color texture 2D. I'm just going to add to it a vector 4, and let's say a vector 4 with 4 values, RGB and A for the alpha. So let's say for the red I'm going to add it 0.5, for the red green, for the green I'm going to add it 0.2, for the blue 0.4, and for the alpha let's say 1.0. And now let's run this and test if it works. So as you see, now our UFO is colored with this pinkish color using the Fragment Shader. And if you don't want to see the image rectangle, then the last value, which is the alpha, just set it to 0. So now we overwritten the pixels of this UFO animation or this UFO sprite sheet using shaders, using the Fragment Shader. And I think I'm going to end this video because it's already more than half hour long. So maybe later I'm just going to showcase some, in the next video, I'm just going to showcase some of the possibilities what can you done using shaders. So until then, thanks for watching and have a nice day.